So with CodeRabbit, we are working on transforming the code review process using AI. Talking about our journey, we launched back in July. We were fortunate enough to have our initial funnel of customers for the first few months who really helped us mature our product. And since then, we have been getting a pretty good traction. Currently, CodeRabbit is in use at over 400 organizations for reviewing the code as it gets merged into the main code base part of CI/CD pipeline. So talking about the existing code review process, there is some automation in terms of linters and static code analyzers. This is good at finding code styling issues, syntax errors. The static code analysis is good at identifying security vulnerabilities, performance issues. But what these really lack is a context-aware review based on the functionality, the coding practices of an organization, the design patterns that they follow, the intent of the code changes which are being made. And for those reasons, the code review up until now has been largely manual. And if we look at the entire CI/CD pipeline, this is the one part which is mostly manual. Otherwise, the entire pipeline is mostly automated. But manual reviews has its own challenges. It's a slow process. There was a recent study by GitLab which showed that on average, a merge request on GitLab took between 2 to 4 days for it to be merged within the main code base. And this doesn't just slow down the developers, it slows down the project deliverables, it slows down the hot fixes that need to go in and they are urgent. Along with that, there's a lot of context switching that happens within the development team. Once the developer creates a pull request, they move on to the next task and they are fully concentrated into that. It depends on when they get the review feedback from the peer reviewers. Could be the same day, it could be the next day or day after. Whenever they get the review feedback, they have to switch between the tasks. They have to move back to what they had fixed with that pull request. And that takes a lot of time and it's training for the developers. In many places, code reviews are actually needed. It's part of compliance. That's why industries have to make sure that the code is reviewed when it's merged into the main code base. But in many places, it becomes a mere formality. It's a rubber stamping. In dysfunctional teams, there are personality clashes between the engineers. Sometimes it gets into nitpicking of the issues. And the last but not the least, because it's a manual process, there is a human oversight that happens. And there was the study by Smart Bear. Recently, they published an article which said that a human brain can effectively review only about 4 to 500 of code in a single review session. So if it really goes beyond that, it's hard to comprehend and find the issues. So this is what we plan to fix with the CodeRabbit. CodeRabbit is an AI-powered code reviewer that provides a context review feedback with the smart chat feature. In terms of the USP, it accelerates the code reviews. There's a very comprehensive review feedback which is available within few minutes. Depending on the size of the pull request, it takes from anywhere from 3 to 6 minutes for the review to complete. But along with that, and equally important, is the AI insights it provides. And this is like, we are learning it more from our customers. What they're finding is that it's finding the issues which are often overlooked by humans. Based on the training data that these the latest models have been trained on, they're really able to find, and they get the developers, the peer reviewers, thinking about the way that they're doing the things. So this is a simplified version of how the product works. It listens to the events from GitHub. Whenever a pull request is created or incremental review is made on the pull request, it does some pre-processing, and part of pre-processing, it gathers additional context that is needed for the review. It gathers the context from the workflow systems. It tries to understand the intent of the change. It looks for the linked issues. If there is a GitHub issue, GitLab issue, there's a Jira or a linear issue which that pull request is trying to address. It gathers that context from the reviews that have happened in the past. There are some learnings which are stored. It gets those learnings. It gets some context from the repository. And it builds this recursive request context. It's sent to the large language models. Currently, we are using GPT 3.5 and GPT 4 Turbo. We get the response back. As mostly all of you would know that there's a lot of inaccuracies in the AI response. There's a lot of hallucination. So we parse the response. We try to suppress the noise. We have certain patterns that we look for. We have certain labeling that we do. After that, we identify if it needs another set of review. If it's needed, we add additional context, have AI do another set of review. This can go at max up to 5 or 10 times. Eventually, once all said and done, the entire review feedback is posted within GitHub. And with that, we maintain the state of the review, which is also stored in GitHub. So in terms of like the core features of the product, it does these continuous reviews whenever a pull request is created. That triggers a review, and along with that, whenever there are incremental changes made within the pull request, based on the state that it tracks, it can identify which specific commits need to be reviewed. It generates a summary in natural language of all the changes. There's two sets of summary. One is like a high-level kind of release notes, which is intended for entire team, including any non-technical folks. And with that, it also does a technical walkthrough of all the changes, like all the files that were changed and what were the changes with that. Along with that, it does assessment of the change set against the linked issues. So whenever a pull request is created, it's addressing some issue. And generally, it is linked with a GitHub issue or a Jira or a linear issue, whatever, depending on whatever workflow system is being used. So it does that first level of validation, whether those objectives are met, and it lists those out. I'll go through those examples later. And then along with that, it also identifies any other related issues within the system which might be impacted with these changes. If there are any duplicate issues that exist, if there are any, let's say if there is like some buggy, brittle code which is broken often. So with this, it would identify and it lists all the issues which were, let's say, fixed around this code in the last, let's say, like 1 month. Next, it does a line-by-line review of each and every diff, which is part of the pull request. The review is posted as review comments on GitHub, and if there are any in the suggestions, if there is any code that needs to be changed, that's posted as committable suggestions, which can be committed within the pull request with a single click. And it does verification of these changes outside of the change set, which is part of the pull request. So let's say, like, within the pull request, if there is a code which is being changed, which is referenced anywhere else in the entire repository, so it can do that recursive lookup in the entire repository, and it points out to, it first checks whether the code, wherever it's referenced, whether that has been updated or not. If it's not updated, within the review comments, it posts that this needs to be addressed as well. You can chat with the bot within the review comments. Once the review is posted, you can ask more questions to the bot. You can provide more context. You can have the bot rewrite the code, have it write like test cases, unit tests, things like that. And another interesting feature with this is, like, when you have conversations with the bot, we parse those conversations, and out of that we identify the learnings based on the user interaction. So if there is a review which is not applicable for, let's say, organizations' coding styles or the patterns that they're following, so once the peer reviewer or the developer, once they tell the bot, we pass those, we store those as learnings for the future reviews. So when the future reviews happen, then the reviewer has that context that is needed. And along with that, it adds the learnings, and with that, it also removes the learnings. Because over time, the coding styles change, practices change. So some of the learnings become stale. So it autonomously identifies the learnings which are old based on the comment that the developer or anybody in the team leaves. So it removes the learnings. It's pretty important for us that the learnings are always up to date. And through the chat, you can get any insights into your code base. So for instance, you can ask questions like, which are the most frequently changed files in the last 1 month? What are the issues which were closed in the last 1 week? Who are the top contributors in this repository, in whatever time period? So the next piece I want to touch on is, there are a lot of tools, lot of products that are coming in to assist the developers in this journey. So in the AI landscape, this is how we vision it's going to turn out. So for a general knowledge base, you have chat bots like ChatGPT, Perplexity. And then as the developers start coding within their IDEs, we have products like GitHub Copilot, Cursor. But then all the code that is being written, it needs to be reviewed as well. And there are multiple reasons for that. So irrespective of whether the code is being written by a human or by the bot, the code still needs to be reviewed, because the context is different. When the bot is writing the code, the context is very limited to let's say the class, the function within which it's writing the code. When it's reviewing the code, the context is much larger. It has to look at the entire repository. It has to look at what the intent was, what the issue was that I was trying to fix. So that's where we think there's this need for AI code reviewers, and that's how we are seeing how our clients are using it as well. So now let's look at some of the examples. So I'm not going to do it real time, because the code review, the entire process takes about 4 to 5 minutes, but I'll go through some of these recent reviews. These are in open source. So when the review is posted, there is this a high-level summary. It lists out like what the changes are, what the new features, enhancements, bug fixes, documentation updates, etc. And then there is this more technical code walkthrough. This is really intended for the peer reviewers. When they start looking at the pull request at a high level, it gives a pretty good idea what are the files changed and what were the changes in those. And then it does this first level of validation against the linked issues. So in this case, this pull request is addressing this issue, and it lists out all the objectives. It lists out which were addressed and which were not, which it's not sure about. So, for instance, in this case, one of the objective of the issue was the documentation needs to be updated and update relevant user guides. So those were not updated, and it explicitly mentioned that. And if we look at the change set, we can see that the documentation was not updated. So this is like the high level summary. Now I'll I guess take a little bit more into the actual reviews. So in this case, for example, like CodeRabbit left a review comment. It said it's important to handle the potential undefined values that could arise if the cache does not contain this key. So to this, a developer responded correct point, but it's better to use non-null assertion operation since newly created regex object must be cached. And based on that, it looked up whether those objects which are being cached are always being cached or not. And then it provided this suggestion that this is what you should do, which the developer accepted and said it fixed with this commit. And when the developer leaves this comment, then the bot actually goes in and it reviews that specific commit to make sure that change was actually made or not. Let's look at this learning example. So in this case, the CodeRabbit review complained about the validation, that this isn't being validated, and the developer said that the validation is being done in this simulation file. And then it actually went in, it checked the simulation file whether it had the validation or not, and it found that there's a check load balancing function which had that validation. And there's this analysis in. So in the reviews, we are providing access to the shell scripts. So AI is generating the shell scripts to do this verification. So in this case, for example, it ran this shell script, and along with this, it generated this learning which is used for the future reviews. So the user has clarified that the validation for the load balancing parameter is handled in the simulation file through check load balancing function. So now whenever it's going to review the next pull request, which is using the same function, it would know that this is being validated in this specific file. This is another example where it does that recursive verification. So in this case, the user is renaming this TEMV contract to a contract, and this is what is intended with the pull request. But with the recursive review, so when the AI did the first level of review, it mentioned that the TypeScript declaration of my contract is updated in the contract type, which should be verified for consistency across the code base. So based on this, we run a shell scripts to identify whether it is consistent or not. And with this, it identified that the shell script output indicates there is at least one instance where it's still mentioned in the code base, specifically in this specific file. So I had some more examples, but I guess for sake of time, I'll skip those. So the sign up is pretty straightforward. If you have a GitHub, GitLab account, within a few clicks, takes less than a couple of minutes, you have the CodeRabbit app installed on your repositories. And once it's installed, it starts listening to all these events that do the reviews. You get a free trial for 7 days, but there's this coupon which can extend the trial for a month. Open to questions. We started with shell scripts. We are working on opening up another additional commands. We giving it access. We are testing through that process. No, we don't have our own models. We tried with some open source models a few months back. It's nowhere near the quality that we get from OpenAI latest model. So we plan on using the best-in-class models, which happen to be the OpenAI models at this point. Regarding your second question, it's in the privacy policy of OpenAI that it does not use the requests that are submitted through the APIs. So it does its learning on ChatGPT, not through the APIs. And on our side, if you're using our product on open source on the public repositories, then we do some logging, and because we have to improve our product, but we limit it only to the open source repositories. As of now, I think the compliance needs a human as well. So the general workflow is that this like our product does the first level of review, which makes it much easier for the peer review to come in later and finish it off. So for learnings, we using RAG, retrieval augmentation. We augment the model. So once we have the learnings, when we review that same code or related code next time, we add that additional context. Part of the reviews, once we get the reviews back, we do another level of verification whether it really used that context or not. But it's short-lived. It's only for that specific review. Yeah, we cannot. So when we do a review, it's a multi-stage process, and part of that, like all the context that we gather, be it from the repository or the workflow systems, we summarize that, and then once we have that summary, then we create another like a summary of summary, and as we have additional context, it's just like a recursive summary. We just keep on adding to that.